Hello, this is Kevin Cofield with Cofield Aviation. In this video, I wanted to kind of explore and show you the world of weather models and how they can play a vital role in basically planning for a flight, 6, 7, 8 days in advance. So in this first video, we're just going to focus on a long-term flight, maybe 3 to 7 days in advance, and kind of go through how I would look at these models to kind of predict what weather will be forecasted, what the winds will be, what the cloud heights will be, if there's any convective activity, rain, and so forth. So let's go ahead and get started. So this is probably the best thing I've learned in the past several years in aviation is the weather model data. So the website we're going to go to is called pivotalweather.com. So I'm just going to put it in here, there it is, pivotalweather.com. Just tap it in there, hit go, and it's going to pull up the website. And if you see right here up the top, we've got the model. So that's what we're going to click on. We're going to click on models and bring that up. Now, there are several different types of models. Now, if one model was accurate all the time, this is just computer models. So if there was one model that was accurate all the time, we'd only need one model. So we're going to basically look when we're looking 3 to 7 days in advance, and it can even go well beyond 7 days, but really beyond 7 days, it's not accurate in the least. So really, we only kind of want to start paying attention to it 3, 5, 7 days in advance, and then kind of see how the models trend, either better or worse, as we get closer to the flight day. So this is what comes up. So I'm going to zoom in right here. If you see model, there's three different things: model, zoom, and animation. So we're going to go to model. We're going to click on that, and this is going to bring up all the different types of model. If you see the global model there, that goes out, the CFS goes out 768 hours, so that's a long time. The GFS goes out 384 hours. That's American model. The ECWMF, that is a European model. So really, I kind of bounce back and forth between the GFS and the ECMWF, which is a European model. When we get towards the regional, if you see the regional and the NAM, that's only 84 hours out. So that's going to be in the next video when we start exploring those. That really gets a lot more accurate in planning, 2 to 3 days in advance, and even more so when we get over here to the convection allow, and these get very detailed, only going 60 hours out to 48 hours out. So anyways, what we're going to do is we're going to go to the GFS first. Now, I'm doing this on a Saturday, so we're going to plan a flight for, let's just say, next Thursday. Maybe we want to go from Gadsden to Orlando, take the kids to Disney World for a long weekend. So we're going to look at the weather flying from Gadsden to Orlando next Thursday, and we're just going to see how it looks. So we've selected the GFS. That's that model right here. Let me click off this. So the model, we've selected GFS. Now the zoom, we've got this on the whole entire continental US. We can click this zoom button here, and this is where we can kind of dial in and look at more specific things. So if I'm flying halfway across the country, obviously I'm going to leave the continental US up there. But for this trip in particular, we're just going to look for Gadsden to Orlando. So we're going to look in the southeast. So if you see regional there, we're going to click regional. And then we're going to click the United States. And we're going to click here the southeast. And then that's going to zoom in on just the southeast United States. So that's just exactly what we were looking for here in our flight to Orlando. Next is we're going to go to animation. So right here it shows single image. So we're going to click on that. We're going to make it a loop basically. So if you see the forecast loop in the top left hand corner there, we're going to click forecast loop. That'll give us a slide that we can slide through to see kind of how the weather's going to go. Let's just say wife and kids don't want to wake up early, so we're going to leave at about 10 a.m. So in standard time, right now we're adding 6 to get to Zulu. All this is in Zulu time, which we know well as pilots. So we're going to look at 16Z departure, say about a 3-hour flight down there. So we're going to be looking between about 16 and 19 Z to see about what the weather is going to be. And then maybe we have to adjust that time of our thinking. But anyways, up here on the top left, this is the latest run. So we want to make sure that we are looking at the latest model run. So if you see Saturday 122 there at 12Z, you can just click that and make sure that it is the latest. And if you see here, it is. Here's all these runs dating back, 3 or 4 days in advance. But this is the latest run, so we'll make sure we're on the latest run. Now from there, all we're going to do is use this scroller here, and we're going to scroll through and get a depiction of what the weather's going to be like for Thursday. Okay, so let me just kind of show you how this moves. Almost looks like a radar as we scroll through this. So we're going to go to Thursday. So here I'm at Thursday. Here I'm at Thursday at 15 Z. And if you look on the surface, it looks like the weather's probably going to be pretty fine. Not showing any sort of precipitation along the route of flight. Obviously, this is many days in advance, so things can definitely change, but this is going to give us a broad idea of the weather. So right now, looking at this, I'm thinking, okay, it doesn't look like there's any precipitation, but now we're going to take it a step further, and what's the cloud heights going to be? That'd be really important if we can fly VFR or not. If we're instrument rated, cloud heights mean a little more in January, February for icing. So we're going to kind of see, based upon something that's called a Skew T diagram, we're going to see where the cloud height's going to be. Maybe I'm going to be cruising at 7,500 feet. So am I going to be in the clear? Do I have to worry about icing and so forth? So that's where we're going to take this next step now. We're going to leave it on 15Z. We can also go here to 18Z, and you see nothing really is changing in that short few hours. But we're going to go to 15Z, and what I'm going to do is I'm going to zoom in on Gadsden. I'm going to zoom in right here, and I'm just going to click where Gadsden is at, so basically right over Etowah County. So I'm going to click on that. What that's going to do is bring up something called a Skew T diagram. Now, this thing can look extremely confusing, but we're only going to focus on a very small aspect of it. We're going to be looking at cloud height and winds, right? We'd like to know what the surface winds are going to be, where it's going to be out of, west, north, or whatever. So I'm going to zoom out here. Again, this is the Skew T diagram. All we're going to be looking at is this area right here. Now, let me explain this just a little bit. Now, the red line is the temperature line. The green line is the dew point. So what do we know when temperature and dew point come together or get really close to each other? Where these lines are getting close to each other and almost touching, we're going to be looking at clouds, right? Where they separate, there's not going to be any clouds. We know when temperature and dew point get close together, that's going to be where clouds form. So at the surface right here, it looks like we're probably going to be in good shape. Possibly have some, well, let me talk about altitudes here. So if you look right here on the left, this red here, that's the kilometers above sea level, okay? The 1,000, the 850, the 700, the 500, those are millibars. That's pressure, okay? So as we know, we're kind of in the bottom of the pool at sea level, so we got the most amount of pressure, the air pressure above us. But basically, the 850 millibars is about 5,000 feet, close to that. The 1 kilometer is around 3,000 feet or so. The 700 millibars is around 10,000 feet. That's an estimated guess there. So flying small single engine airplanes, we're only going to look between the 700, 850, and 1,000 millibars because 700 millibars is 10,000 feet. We're not really going to be flying well above that. The 500 is about 18,000 feet. The 300 millibars is about 30,000 feet, and so on. So obviously, no need in a small, unless you're flying a jet, no need to really look at that. So based upon this, it looks like you might have some very few clouds really close to the surface, maybe about 700, 800 feet. But with the spread that it is there, probably would be an issue. So I'm anticipating over Gadsden basically clear skies. And if you see right here where that green line goes far left, means it gets really dry air. So even if there was a very small layer at maybe 700-800 feet, it's going to be extremely thin. It's going to be beautiful skies above that. Remember, temperature and dew point get close together. That's where clouds form. So we're looking at where those lines get close together. Now, where they're touching is typically going to be solid overcast. As they get further apart, now we're talking more broken, scattered, few, and then eventually they get so far apart there's going to be no clouds whatsoever. Based upon this right here, I would guesstimate that there would be no clouds there. Okay, if you see down here the -40, -30, -20, -10, and 0, that's your temperature. And then these lines, if you see the 0, and there's a blue line kind of going diagonal towards the northeast, that is the temperature line. Okay, so that's where we kind of determine where icing conditions are, possibly could be. It is going to be below freezing where those cloud height can be. So if there was some clouds there, might be a concern, but a little moisture really wouldn't be too concerned there. So overall, it seems like probably clear sky. So that checks the box on clouds. Now let's check the box on the wind. So we're going to look at right over here on the right, and it looks like pretty much winds are calm. If you see these up and down orange dashed lines, and you see the red um, lines going left or right there, that's wind speed. That first little diagonal, or that first dashed line going north and south there, that indicates 20 knots. Okay, so this first wind bar is going to be what basically the surface winds are going to be, because the airport elevation at Gadsden is about 600 feet. So we're going to be looking really close to this 1,000 millibars. Basically, where that red line is starting is the altitude that we're going to scroll over here. So looks like probably winds fairly calm, maybe out of the southeast at maybe 5 knots or so. So looks great as far as the weather's concerned in Gadsden. So now we can take this same thing and go along our route of flight towards Orlando. So we're going to go down here, maybe over Columbus, Georgia. We're going to click on that. That's going to bring the Skew T diagram for that exact location. We're going to scroll over here, and here we go. So that looks like probable clouds. Now, if we're flying VFR, it's probably going to be skies clear over Gadsden. Let's see what the height of these clouds should be. Remember, in the 700 is about 10,000. The 850 is about 5,000. 1,000 millibars basically being at sea level. So if you look, these clouds, looks like we've probably got a solid overcast at maybe about 3,000 feet, probably 3,000 feet or lower. And then with this dew point, which is the green line going far left, that means it's going to be sky clears above that. So if we're flying, we take off at a Gadsden, we go to 7,500 feet, this is going to be no issue over Columbus. You will have a solid overcast layer underneath you, but you can maintain VFR for private pilot with no ground contact. Now, risk management, obviously, you have an engine failure, you can't see where you're going to be putting it down. You've got to go through a layer, so take that into mind as far as risk management. Just because it's legal doesn't mean it's smart. But anyways, that's the cloud heights looking good there. Let's go over here to our winds aloft, because we'd be in the air here. We're going to be at about 7,500 feet, so right between 700 and 850. Winds aloft, well, looks like we got a tailwind. Winds coming out of the northwest at about 10 knots or so. And these are the same barbs that we look at in the weather information videos. So if you're not familiar with determining wind speeds via that one's 10. The one above it, which is coming from the northwest, is at 15. So weather's looking good so far. Let's scroll back out, bring up another Skew T diagram. This time we're going to come right over Orlando. We're going to try to find as close as we can to Orlando and click it. And here's a Skew T diagram coming up of Orlando, and looks like about the same thing we saw over Columbus, about 2,500, 3,000 feet. We're probably going to have a overcast or broken layer. So that might create an issue. Again, this is looking several days out in the future. So a lot of this is going to change, but it's going to be the same thing in the next video. When we're looking, even a few hours away, we can pull up these same Skew T diagrams and see what we're looking for. So remember, 700 is about 10,000, 850 is about 5,000, 1,000 is about sea level. So it looks like we'd be in the clear above 5,000 feet, even in the Orlando area. And then the winds, it looks like the winds are going to be fairly gusty out of the northeast. So now I can kind of already be planning, taking off into Gadsden, winds are going to be kind of out of the south-southeast. And then landing in Orlando, the winds are going to be probably out of the northeast. So now I can go ahead and start kind of planning what runways I'd be taking off on Gadsden, what runways I'd be landing at in Orlando. And if we're instrument rated pilots, we can go ahead and start looking at departure procedures for departing towards the south out of Gadsden and arriving towards the northeast, finding a runway that would facilitate that, and go ahead and kind of look at the approach and look at the notes and brief it and see if there's anything crazy going on. So anyways, that's how we're kind of looking at a forecast long range using pivotalweather.com and the model data. It's really good stuff. And we can do the same thing. Again, we're in the GFS model, so we can do the same thing with the European model. And I'll just show you that very briefly. Now, before I go, if you see this METAR right here, we can type in a METAR. So let's just say if we were going to Orlando Executive, which is KORL, we can put that in there. We can hit enter, and it's not liking that. Okay, there it goes. So KORL, hit enter, and that's going to bring up the Skew T diagram for that exact location. If you see, I was probably pretty close from where I put my finger on it, because this looks very similar to the Skew T we were just looking at. Again, cloud height's probably right at about 2,500 feet, probably starting at about 1,500 feet and maybe 1,000, 2,000 feet thick or so. And then obviously clear skies above that. So as an instrument rated pilot, you're looking at this and going, yeah, no problem. I'd have to, shoot an approach, get below the bases, but should be no issue there. And again, the winds are still showing winds out of the northeast at about 10 knots. Okay, let's zoom this out, and really briefly, we're going to change the model here and see maybe how it looks different. So we're going to go right up here to the model. We're going to hit that, and we're going to change this to the European model. So I'm going to go to the ECMWF high resolution data. Now we cannot pull up Skew T diagrams on the high resolution European model, but we can still look at how precipitation is looking. So I'm going to click that real quick. And it's going to keep me in the forecast loop. It's going to keep me looking at the southeast United States. And I'm just going to go here to the top left, just like we did a second ago, and make sure we're in the latest run. Yep, we are here. So we're going to pull that up, and it's just going to be a simple scroll through here until we get to Thursday. All right, so there is Thursday so it goes from 12Z to 18Z, so I'm going to look at 18Z. If you look, the European model and the American model are pretty close together in what they're showing precipitation and stuff, but if I try to click on something, it will not bring up that Skew T diagram. But you can do these with any of these models over here. But again, I typically like to use this European model, and I typically like to use the GFS model as well. So anyways, that's a snapshot of how I'm looking at model data to plan a flight several days in advance. And this is probably the best thing I've learned, like I said, in aviation in quite some time. I mean, because it really gives you a scope. It's almost like you look at future radar as far in the future as you need. Just real quick here, I'm going to go back to national, bring up the whole U.S., and then I'm just going to kind of show you what that looks like as we scroll through. So this is the 22nd of January, and we can keep scrolling through and see what the weather's going to be looking like for several days in advance. But keeping in mind, obviously, that the further you go out, the harder these models are to be accurate. So we don't really want to be relying on model data more than 7 days in advance. And even model data, 4 to 7 days in advance can be very kind of skewed. But as it gets closer and closer, especially the day prior, that'll be the next video of looking at a flight, 3 days or less in advance, we can really start to get more accurate and the models start to converge, and then we can kind of get a greater idea. So anyways, hope this helps. If you got any questions, feel free to shoot in the comments, and I appreciate it.